We all know AI can write essays, it can create some seriously stunning images, and yeah, it can even debug our code. But what about the ultimate creative test? Could an AI agent actually build a complete, functional, and, fun video game from the ground up? The question isn't just if AI can code a game, it's if it can truly create one. Let's find out.
And look, we're not talking about just spitting out a few lines of code here. This is a huge task. It's like a symphony of logic, art, and interaction where every single piece has to work together in perfect harmony. So the big question is, how do today's most advanced AI agents actually stack up?
You have to remember, building a game is not just about the code. It's this incredible, intricate dance between what you see on the screen and the logic running underneath. It's knowing how a character's running animation, a visual asset, has to connect flawlessly to the player's button press, which is pure code. It's a world where what you see and what you type are deeply, fundamentally connected.
So, to get to the bottom of this, here's what we're going to cover. First, we'll look at the next big frontier for AI. Then, we'll introduce a brand new benchmark that puts these AIs to the test. After that, we'll see how they did, uncover the surprising key to success, and finally, talk about why this is such a big deal for the future.
Okay, so the first thing we really have to get our heads around is the massive gap between the kind of AI we have today and the AI we actually need for a job like this. And it all comes down to a fundamental difference in how the AI sees the world.
Let me break it down like this. A code-only AI, what we call a unimodal AI, is like a brilliant author who's been blindfolded. It can write beautiful, functional sentences. That's the code. But it has no idea what the illustrations in the book look like. A multimodal AI, though, it sees the whole picture. It gets how the words and the pictures have to work together to tell the story.
So, to properly test these advanced multimodal skills, researchers had to develop something new, a really, really tough evaluation. You can think of it as the Olympics for AI game developers.
It's called GameDevBench. And get this, it's the first ever standardized test that drops an AI into a real project inside a modern game engine, in this case the popular open source engine Godot, and tells it, okay, solve this problem, just like you'd ask a human developer.
And what you're seeing here really shows just how complex this gets. A task like create a minimap isn't just one line of code. No way. The AI has to navigate this visual editor, it has to understand different file types like images and textures, and it has to edit these dense configuration files, all while making sure everything plays nicely together.
All right, so we've got the ultimate test. They throw the world's most advanced AI models at it. So, how did they do? Well, the results weren't just surprising, they were a huge reality check.
So here it is, the headline number. The absolute top-performing agent, Google's Gemini 3 Pro, only succeeded on 54.5% of the tasks. Let that sink in. One of the most powerful AI models on the planet failed almost half the time. This tells us game development is not just another coding challenge, it's a genuinely hard problem for today's AI.
And when you start to break down the numbers, a really clear pattern just jumps out at you. The agents were, well, okay at gameplay logic, things like collision detection. But their performance absolutely plummeted on tasks that involve 2D graphics and animation, dropping to a success rate of just under 32%. This is exactly where that whole multimodal thing really matters.
And this poor performance led the researchers to a critical insight, a real aha moment. Maybe the problem wasn't that the AI couldn't code well enough. Maybe the problem was that it couldn't see. It was flying blind. So they decided to run a new set of experiments. This time, they gave the agents a simple but totally revolutionary tool, the ability to take a screenshot of the editor or record a quick video of the game. And the results? They were nothing short of dramatic.
This right here is the perfect example of the problem. So the AI is smart, right? It correctly figures out that it needs to add a sub_emitter property to create a splash effect for rain. But it puts that line of code in the completely wrong place, under the material properties instead of the particle node itself. You see, it knew the what, but it had no clue about the where. It was missing the spatial, structural context that a human just gets by looking at the editor.
And the results with this new approach were just stunning. When another powerful model, Anthropic's Claude Sonnet 4.5, was given video feedback, its success rate skyrocketed from about 33% to nearly 48%. That's a 42% relative improvement, just from letting the AI see the results of its own code. It could now visually debug its own work exactly like a human developer does.
So, you might be thinking, okay, that's cool for making video games, but why does this really matter?
Well, this is about so much more than just games. This points to a fundamental shift in how we need to think about building capable AI agents for pretty much any complex real-world task. So, let's just quickly recap the big takeaways. First, game development is an incredible new testing ground for pushing AI way beyond just simple code. Second, it turns out the biggest hurdle for these agents isn't language or logic, but a serious lack of visual and spatial reasoning. And finally, this all points to one thing. The future of AI is all about combining code intelligence with a true, deep understanding of the visual world.
Which leaves us with a really fascinating thought to chew on. For years, we've been focused on teaching AI to write. Now, we're finally teaching it to see. The real question is, what happens when it masters both? What becomes possible when it can do both as well as, or maybe even better than we can?